Welcome to From Cover to Code, the Technology Book Club. Join us as we discuss artificial intelligence, DevOps, software development, cloud computing, and more. With your hosts, Angela Andrews and Michael Jenkins. The next episode of From Cover to Code starts now.
And we are live.
We are live.
Yes,
Hello.
indeed. How are you doing today, Angela?
I'm humping on this here hump day. Yes, I am.
I know, right?
How are you doing?
I'm good. I literally ran into the studio today, pulling my book and my notes behind me, like, can I make it? Trying to get here to the studio on time.
I love it.
Because I was literally reading these past two chapters down to the wire. They're packed, but I mean, we'll save that for discussion in a minute, just to kind of get settled here.
Well, if anyone's following along and keeping up with us, you will know chapters 3 and 4 definitely could have stood on their own. Like they don't need to hold hands. They need wide berth on the sidewalk. Like that's how serious these chapters are. But we're here, and you know what? We're gonna get into it. So
yeah, indeed. So thanks to everybody that's joining us. If you're joining us live, watching the replay on LinkedIn or YouTube, watching the broadcast on YouTube, or you're listening to us on your podcast device, podcast application. Thank you for joining us. And yeah, this is one of those discussions where I'm like, I mean, you know, when you come in with a plan, it's like, yeah, we're going to knock out two chapters in this episode. It's going to be great. Bruh, let me tell you, each one of these chapters, we probably could do a whole season on the depth of AI, the depth of machine learning, and the depth of generative AI, and how they all come together. I mean, to provide the services that we know, we just like type some stuff. Hey, give me a poem, you know, to write this email to my boss or whatever, and it just happens. If you know the science and the math and the research and the definitions and all the other stuff that goes on behind the scenes of Chat GPT or whatever model you're using, man, it is mind blowing.
Yeah, respect to all the data scientists and mathematicians and PhDs who are putting this together so us, the end user, can use it seamlessly without the need for this backstory. But because the backstory, depending on what sector you work in, is actually very important. And at least on the level of a passing understanding where you could have a conversation and you can recall, oh, I know these terms and these phrases. I know the different types of modeling. I understand the different tooling that AWS, which is the cloud that we're focusing on, what those tools are and how they're used in AI and ML.
Yeah, indeed. And I'm like, at first I won't say I got mad, but I'm like, hey, I'm just trying to be a practitioner, y'all. I'm just coming in here, you know, trying to get the basics, trying to get the certification. And then, you know, let me get a little bit deeper. They're like, nah, what you're going to do is you're going to understand the foundations of machine learning, AI, generative AI, and what you can do with it, foundational models and all the other tools that AWS has for all these different things. Like I said, we will get into that discussion. I'm literally getting ahead of myself because there was so much going on in these two chapters.
So the author of this book, Tom, he's basically like my mom. When she wanted to teach me how to swim, she just threw me in 10 feet of water. And I think this is what Tom is doing right now. And I am a very good swimmer. So I hope this pattern can continue with this book.
Yeah.
Dude threw us in the deep end and didn't even give us a life preserver. He just standing on the edge saying, "You can do it."
Yeah.
Are you sure?
Yeah, no shortcuts, no soft blows, no pulling back punches. He was like, "Hey, let's get real with this material."
All right.
So yeah, so you want to jump into this
Let's get into it.
discussion?
Let's get into
Um,
it.
yeah, indeed. And what I'll do as we're doing this, I'm going to fix this little banner that I have, so we can focus on one chapter at a time. I had
Very,
both chapters on there, but
very.
let's start with chapter 3, AI and machine learning. I mean, since I got the mic, I'll just go ahead and start and say he kicked it off with, like, a lot of people misunderstand what AI means, and even though that's the case, you should understand it from AWS's perspective. And so he offered their definition, which is artificial intelligence is a transformative technology that enables machines to perform human-like problem-solving tasks. So that's kind of like our foundation to run from. And there was a link in the book as well to Amazon's article, What is Artificial Intelligence?
Mm-hmm.
And I think that is also like recommended reading for a companion to this chapter, because it gives a little bit more background on some of the tools, the services, use cases, and so on.
Agreed. Well, the book starts at the start. It always starts, not all, but most chapters like to start with a little history lesson, which
Mm,
I always respect, where the term was coined back in 53 by John McCarthy at Dartmouth. Like, they get so
mhm,
specific, but
right.
you have to know where you've been to know where you're going. So I understand that. Um, and then it gives this really good level definition that you just gave. And on the next page, it breaks it down for you. So when the regular layperson, which me and most people that I work with, when we're
Mhm,
talking about AI, we're talking about generative AI. We're talking
mhm,
about the chat GPTs, the Copilot, the Perplexity, Claude. We're talking about putting something in and getting something back out.
mhm.
But that is the most inner circle of AI. If we're talking about it as a whole, it
Yep.
has very various layers, like a parfait, right? It has
Mhm,
various layers. So it starts with AI and that definition that you gave, but there is a subset of it that goes a little bit deeper, and that's machine learning,
mhm,
and that's the act of the where the computers learn from their data. And then it goes a little deeper up into deep learning, where
mhm.
they talk about maybe the neural networks and things like that, and the scientists who created and championed in those realms. And then it goes into generative AI, which is what
Mhm.
we mean when we say AI, day in and day out, our little chat
Yeah.
bots and this, that, and the other. That's where that resides. But again, this is a whole scientific practice,
Yeah.
and it really does deserve the understanding if you're going to work in it. AWS does a great job with I don't want to give too much ahead, but SageMaker is that girl. Like, she does it all.
Yeah. I was really impressed by I mean, the breadth and depth of the services provided through SageMaker. And just for keep everybody on the same page, Amazon SageMaker is a managed service that helps with building, training, and deploying machine learning models at scale. So this, like, SageMaker is really focused on the machine learning portion of it, where you're getting your data, you're cleaning your data up, you're using your data to train a model, either a model that you built yourself, one of the models that they provide, and then you're making that model available for use in an application. And those applications can be varied and assisted by the other services that are a part of SageMaker.
Yep.
And we'll get into that in a minute. But the author described, like, the different parts of SageMaker: Studio Classic, Notebook instances, Jumpstart, Data Wrangler, Model Monitor, and ML Ops tools. Maybe we can talk about some of those specifically. I've got my favorites of some of these
Okay.
tools. Um, before we get into the ML lifecycle, I don't know. Do you have any thoughts? Any other thoughts on SageMaker?
Nope, I'll wait. But there was back in the beginning of the chapter, there was a mention about, data. This is all about data, all about good data, all about clean data, all about high quality data. And when I saw it, I'm like, okay, we think, well, data is data. If you're scraping the internet, you're gonna get what you get, right? But the question I had, again, they said the more data, the better, especially if it's high quality. And I was like, well, let's clarify what that means in this respect. And it's that data sets that are accurate, complete, consistent, relevant, representative, and in good data at the end of it impacts the model's performance. So again, when we were talking about the different types of AI and the parfait that we were referring to, um, it goes into a lot of the use cases in each subset of AI, or subset of AI, then subset of ML, then subset of, they're all subsets of one another. But they also go over some of the use cases that we are very familiar with. And if we're pairing it to Amazon tooling, we should probably give it the respect it deserves because this is definitely an Amazon certification. So I guess the first one we have AI. And then in the book, it says something about examples of ML use cases. And there's like fraud detection, predictive analytics, recommendation engines. And, you have your favorites, I'm sure, right? What are some? Because I have one sitting next to me. She's listening to everything I say. We're talking about, which one is yours?
Yeah. You don't want to say your friend's name because your friend will probably like turn some lights on or do something like that.
Actually, that's a subset of deep learning, not ML. So that was my mistake. If we're talking about speech processing, then it goes down to the deep learning level. So but let's go back to ML. Let's go back to
to machine learning.
Yeah. What do you think? What are some of your the ones that you're familiar with? Or
I really enjoyed working with the notebook instances in SageMaker. Number one, if you're working like I like Python. I mean, everybody knows that. Pythonista in the building. And and it gives you this like really slick Python interface on a managed server. You don't have to install anything. All the libraries are there. Really slick interface. You can just start typing your code in cells, get the results and output right there. And the capabilities as far as like reading the data in, saving the data, you're basically in the AWS ecosystem. So you got access to S3, you got access to Lambda, and you can hook all these things into your Jupyter notebook and just like out of the gate, you're ready to go. So
you're off and running.
I'll put a pin in story time. I don't want to derail the discussion, but maybe towards the end of the show or end of the discussion, I'll share some story time about working with Jupyter notebooks in SageMaker.
Okay, awesome. So if we're talking about ML use cases, good old Netflix, what would we do without them giving us those, using the recommendation engines? I wouldn't know what to watch next if it weren't for Netflix, because I don't watch a lot of anything unless Daryl puts it on television. So if it weren't for Netflix, I probably wouldn't.
I know.
Watch next, please.
And we feed the engine too, because after you finish watching a show, well, even before you watch a show, you're browsing it and you spend a little bit of time watching. They're like, hey, they spent some time on this one. Maybe they're interested in shows like this. You click in, you want to see the number of episodes or the movie description, and then you watch it, and then you give it a 1 thumb up, you give it a 2 thumbs up, and they're like, oh, okay, so if they like this, then they'll probably like something similar, same actor, same storyline, same theme, same concept, something like that. So yeah, Netflix is a good example of those recommendation engines working off of like good data, because it's coming from the user and it's clean and well structured. So they can work with it right out of the gate.
So let's see, what are we going to next? Are we going to talk about?
Well, I mean, he kind of broke it up a little bit, talking about the ML lifecycle, and then into the SageMaker tools or the AWS machine learning services and tools. But since we're there, I have a document that I wanted to share for the folks that are watching.
Good job.
And I will go through it for the folks that are listening. And I don't know how important knowing all of these services is for the exam.
Very.
The author did make a point to describe them, put them in a table in the book to say, hey, these are the machine learning services, and this is what they do. There's a lot of them. So I'll be real quick as I go through this. Amazon Comprehend is a natural language processing tool. Amazon Translate is a language translation service. Amazon Textract can extract text and handwriting from scanned documents, PDFs, and images. Amazon Lex is used for creation, testing, and deployment of chatbots and conversational interfaces. Amazon Polly allows applications to have lifelike speech.
Love Polly.
I know Polly's crazy, right? Amazon Transcribe has automatic speech recognition and converts speech from text to WAV and MP3 files. Amazon Recognition is a tool for computer vision, identifying objects, people, scenes, and activities in images and videos. Amazon Kendra is enterprise search system for structured and unstructured repositories of data. Take a breath. Amazon Personalize helps create AI applications that are customized based on the interests and behaviors of users for sentiment analysis and marketing campaigns. And AWS Deep Racer is a 3D simulation of a fully autonomous race car, which is a fun way to learn or study reinforcement learning. Wow.
Period.
Lot going on.
There's a lot, but it's all relevant when we're talking about, if we're talking about AI, being an AI practitioner in AWS, knowing these services will be paramount, because SageMaker is not the only AI service, right? It's probably the biggest, but it's not the only. You just went through that list. And I want to give a shout out to Deep Racer, because if you've ever been to reInvent,
yes,
you know all about it. So, and it uses reinforcement learning, which we haven't gotten to, but that's one of those new AI terms that you have to familiarize yourself with. So if you're a note taker or a flashcard maker, your deck is going to be huge. Like, there's a lot of new languages, new words, new phrases in here that you'll have to understand. And he does actually point it out in quite a few cases where he says, and on the exam.
I put that in my notes. I was like, hey, we definitely got to talk about this, because he said just out of the gate, like, you need to know this. For real. I'll real quickly also go through the machine learning life cycle, which I think is also important to know as you get into the exam, because you're going to be faced with the decision to make. They'll give you some scenario and you have to pick the right step out of whatever the process is. So he described the machine learning life cycle as, number one, a business goal identification. What's the goal? Then the machine learning problem framing, where you even decide, is machine learning the right thing to do on this thing, or can we just use like some regular old process automation or something like that? If you do decide it's machine learning, then you have to figure out your data processing. You got to get your data, label it, or use it as unlabeled, which is called raw data. Is it structured in tables and rows, or is it unstructured, like text or pictures or audio, video? And then only after you've done all that stuff do you get into the model development, where you can use pre-trained models through SageMaker, or get like a base model and start your own training with supervised learning, where you sort the data into categories and use labels and to identify what the data is, or unsupervised learning, where you just give the model some unlabeled data and say, hey, you figure this out yourself. Or you can also use reinforcement learning, which is like we talked about with the Deep Racer, where you give it positive and negative reinforcement, like, yes, that was a good decision, no, that was a bad decision, and then you use those points, that point structure, to drive the model to making better decisions in the future.
Agreed.
Oh, and the last one's evaluation. I guess I didn't bold these. Evaluation. So after you get your model, you figure out if your model is actually good, doing what you want it to do, and then you can tune your model to make better decisions. And there's actually 3 more. You deploy your model, and then you monitor it to make sure it's doing what it's supposed to do. And then he also went into the concept of ML ops, which is basically you take all these steps that I just described and you put a framework around the business decision, the data collection, the model training, model deployment, the fine tuning, or rather the tuning, because it's not fine tuning, evaluation, and so on. So that was like one of those big chunks of the chapter to understand. Is like, hey, there's a process behind machine learning, and these steps are each one's important, and you have to know what those steps are.
I agree. So chapter 3 was definitely the appetizer. I'm assuming I'm going to call this the appetizer for the rest of the book, because it kind of set the stage for us and what AWS has to provide, as well as the different terminology and the different actions, the different types of learning and integrations and development that happens on your data in AI ML. So chapter 3 was definitely the dessert. Excuse me, it's the appetizer.
It's the appetizer.
It is definitely the appetizer. Let's see, what else did I don't think I have anything else. You went over all of the AI services. There is you probably don't have page numbers, but there is a page on here that shows the key components that make up SageMaker. And I think you mentioned them. I'm going to fast forward just a bit. You talked about the notebook instances, but you found out in chapter 4 where most of the focus is going to be is in SageMaker Studio or Classic. Was it Studio or Classic? I think it's Studio. It was the web-based development IDE.
Yeah. So that's Studio. Yeah.
So that's where we are. I'm sure these other components of SageMaker are going to come up again, but keep those in the back of your head. Keep those in the back of your head.
The only other thing I would say about but the model development, when he talked about the unsupervised learning, which I have some experience with, and he talked about DB scan. So my background in system administration and DevOps or whatever, and I'm like, DB scan, okay, that's a database scan, right? And it's like, no, it's density-based spatial clustering of applications with noise. Okay, thanks for breaking that down. Thanks for breaking that down for me, because that's not what I thought that was.
But that's why you read for understanding.
Yeah.
Seriously. I mean, the terminology that is used, and I'm just talking about in chapter 3. We haven't even touched the terminology used in chapter 4. I'm going to be perfectly honest with you. This is a new language, and the words aren't new. I understand the words, but understanding how they apply to AI and ML, this is going to be a learning experience, especially for me. So make note if you're following along. There's a lot. I'm sure when I finally go back and start pulling out the terms and definitions that need to be understood in each chapter, it's going to be a tome. It's going to be a couple pages long, I'm sure, per chapter. Like, I'm not even talking about, the book. No, I think we're going to really get in there. So
yeah, your notes might be longer than the book itself, just like trying to get an understanding.
I think so. So did you do the quiz?
I struggled through the quiz, and I'll say that I got a couple of questions. I didn't do all the questions from both chapters for this particular discussion, but I think I picked 2 questions from both chapters for us to go over.
Awesome.
With the folks in the audience. And I think now, before we get into chapter 4, is a good time to shout out some of the people that are joining us live. We got our good friend, and let me see if I can get my mouse over here. Our good friend Sterling McKinley, who has joined us on this journey. And yes, his comment, Tom warmed readers up with the exam and some surface stuff. Then he abruptly turned the corner and got to the core foundations of AI. That's chapters 3 and 4 in a nutshell.
A nutshell.
Yeah.
Oh my God.
1 and 2. Yeah. Chapters 1 and 2 is like, hey, welcome. You are welcome here. Let's take this journey together. and then you just get slapped in the face.
He just took off like, oh, wait, let me catch up. It was definitely real. I am very interested in seeing what the book has to store, the rest of the book, because chapter 3 was the jump off. There it is. That was it.
Yeah.
Good evening.
We got Tech Coach Ralph joining us. He's saying good evening to those of us that are joining here live. And I'll say good morning, good afternoon, good evening to you wherever you are.
Wherever you're
joining us on the replay or the re-listen or the podcast, the video, however you're connecting with us. Thanks for being here with us today.
Always.
Okay. So that was a good little break, I think, between getting the basics of AI, like old school original AI and machine learning, and now fast forwarding to where we are today. And even like over the past couple of years, generative AI has gotten really popular, but they started all the way back in the 50s with this stuff.
Mm-hmm.
That was one of the points that the author made about neural networks and deep learning, when they started in the 50s with attempts to mirror the human brain. Okay, that's cool. I can.
Good luck with that.
Yeah. I can only imagine the monumental task of doing that. But I mean, here we are today with the different models, the generative AI models, and he went into a point of describing these models, and as we discussed earlier, pointing out the one you need to focus on.
Love that. Please go over. Please put a pin in that and go over it.
Yeah. I got some notes right here between with these 1, 2, 3, 4 models that he described. The generative adversarial network, or GAN, which is 2 neural networks that I thought was kind of cool, is the generator and the discriminator. The generator creates the synthetic data, and the discriminator tries to assess if the data is real or not. And these 2 guys go back and forth until they get to something that's really real. And I'm like, okay, that's kind of interesting. Then there is the variational autoencoder, which also has 2 parts, an encoder and a decoder. And the encoder converts the data into a compact representation called a probability distribution. And the decoder takes that compressed stuff and then reconstructs the data, or reconstructs the inputs in the data that resembles the original input. And the kind of cool thing is that the model learns along the way while it's doing this encoding and decoding process. And the note that the author made was like, this model is really good for creating drugs or discovering drugs, creating sounds and music, and for anomaly detection. So I'm like, okay, that's cool.
Yeah.
And then the one that he called out specifically is the transformer model. And this model actually has 4 parts to it.
Yes.
The input embedding, which converts
wait. Let's talk about what the transformer model, what is the heart of? What is it the heart of? Why is it so important that we're putting a pin in it?
Yeah, well, you go.
No, I was just going to say, because it's the heart of generative AI. So if that's the section, and I see it here, he says it on page 62, the transformer model is the one that is the heart of Gen AI. So very important. Keep that in mind. The other ones are important as well, but that was one of those things he said, put a pin in it. So.
Yeah. So basically, I mean, the way that I took that is like the transformer model, if I'm not mistaken, it's like the basis of the popular models that we know and love today, like Claude, like ChatGPT, particularly the ones that are text-based, because we're giving them some data, some input, the prompt. They're transforming that prompt into a component, or, a format that they can work with. And they have all this pre-trained data that they can match up our prompt with to take all that input and give us our request. They basically literally generate the response based on our input, stuff that they know, and the relation of the data in a multi-dimensional context. Read a chapter. It's bananas.
Mind blowing.
Yeah, right. But I'll give the four parts of this transformer model: the input embedding, which converts words into numerical vectors, and that's where you get into this multi-dimensional space, which is really funky. Positional encoding, which adds information about the position of each word in a sentence, and that's necessary because the model doesn't process all the words in order. Like we might read a sentence from left to right. It's reading it from word 2 to word 0 to word 9. And it needs a little bit more information to know where these words were. Then the encoder stack, which builds a contextual representation of the input sequence. So basically taking that input, that positional encoding, and building a stack that the model can work with. And then the decoder stack, which takes all that information and generates the output sequence. And the one note that I wrote about this was this, and he didn't even refer to it here, but I did make a note. I was like, I wonder if this affects the context window of the models that we work with. And I'll put a pin in that. We'll come back to context windows here in a minute. But I was like, okay, that totally makes sense as far as like that decoder part, taking information from all these different places and trying to produce something to what we know as the context window. One more model, and then I'm gonna take a sip of something because I'm running out of breath over here.
There's one thing model, that I want. One thing I want to say about the transformer model. And it says something, and this is right before it gets to diffusion model. It says the model is complex, but it's really a prediction engine where it says there's really no need to label the data because it's really just doing what you just said. It's analyzing the tokens that you're putting in, and it's putting them in a certain order where they know they make sense or they assume they make sense. So it doesn't have the knowledge. It just basically is good at making predictions. So I'm going to try to put the next lottery number in there, and hopefully it comes out with a really good prediction of what the next lottery number is going to be, because I'm going to use it for all it's worth at this point.
There you go. Might as well. Hey, what do you got to lose?
I have nothing to lose at this point.
Yeah, everything to gain. And maybe that will help with paying off. Like my AI subscription budget has gone from $20 a month to I don't even know how much a month now. It's we don't need to talk about it, but I'm paying too much for AI every day. Okay, there's one last model in the list of models that the author offered, and that is the diffusion model, which also has two parts. It has a forward diffusion, which adds noise to the original data set, and then reverse diffusion, which starts with random noise and systematically removes it from the original data to generate new data, but it has characteristics similar to the input data. And the text-to-image examples that he gave are OpenAI's Taulli, Stable Diffusion, and Midjourney. And if you think about it, that totally makes sense, right? Because you give these models a prompt and maybe even a starter image, and they can use that to create something that looks similar, like make me look like a Muppet. They know what a Muppet looks like, and they know what your picture looks like. So they're going to take those two, they're going to merge them together, start taking out the stuff that doesn't make sense, and boom, you got your result for your generation, your image generation.
Did you do the little follow along with the prompt?
I did not do the follow along. Oh, with the tree floating above the galaxy and all that kind of stuff. No, I did not do that one.
Okay. Well, I mean, I'm looking at figure 4 or 5 at an image created by Taulli, and my image is so close to that where it's almost like, good God, is this this looks like a carbon copy? And it actually returned 2 images, not just one. And they are very, very similar, but they're great. There are 2 interpretations of it. And like you said, if this is using the stable diffusion model and it's taking my prompt, it is just adding, maybe there's a something out there and it's just unnoising it it's unnoising it to return a very unique representation of what I said. So I think that I always thought this was really cool. I saw an example of this at my old job. We had this lab where we were learning AI, and this one stuck out in my head. So because I've seen this one before, I kind of was like, oh, I know this one, not knowing any of the other ones. So this was definitely a learning process for me. But
Yeah.
anyway, yeah, I'll let you move on. I had
Yeah.
to tell you about the photo though.
Yeah, indeed. And I read through it and I saw his his example. It's interesting to me that you got a very similar output to what he got. Maybe it just cut and paste from what it did before. I don't know.
Does it cut and paste?
I wonder. Oh man. But put a pin in that because we'll talk about one of the drawbacks of generative AI in a minute. And I will say I've got 1, 2, 3, 4 more kind of points for discussion in this particular chapter, because I'll admit there was a lot going on in this chapter and I skipped a lot so that I could be here and be present for the discussion today. I'm going to have to go back and read this entire chapter again because there was a lot going on.
It was a lot going on.
Yeah, but he did go on to talk about foundation models, and these are the models that we are probably most familiar with today, particularly large language models. And they're, like we discussed, they're built on the transformer model approach, where they take our input, they do all these things with it, and generate the output that we expect. Particularly, and part of that transformer is the natural language processing component of figuring out what people are saying. So that's what these LLMs are really good at. But then there's also these multimodal models that combine. They're like a, Megatron or like a Voltron of models, where they just like form together and they can understand all different types of content: text, audio, images, video. And they use transformers to figure out what to do with the text, and then they use diffusion to figure out what to do with the other stuff, the images and the audio and the video. And it's crazy, some of the generation that we're getting today. I mean, this in a very short span of time, this part of the generative AI market has really accelerated, where we're getting, just I'm thinking about movies and like video, where we're getting like Hollywood grade style video from a teenager in their bedroom that had an idea for something, and they just typed it into their whatever model they're working with, and they got the result.
Can I put on my ethical hat
Yes.
while we're talking about that?
Of course.
So we know this is a possibility with generative AI. It can produce new material from all of the data that it has, and it gave the data selection. It kind of went over for Wikipedia, web test, public domain books. It has all of these sources, which for some could be copywritten works, right? And they then produce this film, or they produce this music, or they produce XYZ. And sometimes it bears a striking resemblance to something that already exists. Why? Because it is based on something that already exists. And that is the slippery slope that I think when we're using it to I want to make 2 points and then I'll let it go. When we are using this and it's on the back of someone else's works. That's why there's been quite a number of lawsuits about why are you returning my copywritten works and extrapolating from it? You didn't ask for my permission or whatever. That is something that I think won't go away because of just how the data selection process happens. If you are on the internet, you are susceptible to being part of the model. Okay, that's the first thing. The second thing I want to say is that, well, I'll just leave it at the first thing. I'm sure I'm thinking about bringing up the second thing, but that's the main point I wanted to make. Oh, the second thing. I'm here. It's back. It's back. I don't particularly care When I see something that is AI generated, I'm automatically pissed off. Like usually, especially if it's not if it's like a TikTok, like someone saying the talking ginger knob saying if you put me in hot water. Nope, I'm not talking about those. I'm talking about when you go on Spotify and these AI generated artists, and the key word here is art. An art is something very specific. It is very it belongs to someone, right? Someone was creative and created such a thing. I blocked her. I was like, if I ever come across any AI generated music, I want no parts of it, because understand that this is someone's livelihood. This is art. Now, the fact that you can make such art, I think that's great. And depending on the context in which you're using it, that can be totally fine. But to make money off of something that doesn't really belong to you, I don't know about all that. So I'm off my soapbox. That was it.
No, that's good. And it prompted discussion. Tech Coach Ralph jumped in and said, I haven't really seen AI return it word for word. I've covered a few of the copyright lawsuits, and it's more about the training. And that's the point that I was going to make as well, is like, they're training the models off of previously created art. And so then people are generating results that are similar to what the original input looks like. Maybe it's not the same thing, but it's close. And that is where that artist was like, hey, I didn't give you permission to train your model off of my data. And I think the flip side of that is now you have studios and artists and creators that are partnering with the AI providers and saying, hey, if you're going to do this, let's figure something out. Like I'm making the stuff, you're training your LLMs. Hey, we all got to eat. So, let's sit down at the table and figure this out.
I think artists and companies and individuals, this is a learning phase. Governments, everybody is learning how to deal with the new normal. This is no exclusion as to what's happening right now. You have to learn how to coexist, right? Because the technology is going to keep moving forward. It's not going to stop just because somebody has an attitude about something. It's not going to stop. So I totally understand that 100%.
Yeah. Ralph, Tech Coach Ralph, we're going to get to your comments. I just want to get through my last couple of points, and then we can get into all the discussion about still talking about the foundation models. A couple more points that the author made were about optimization, fine tuning, where you can take these models that have already been trained and you give it just a little bit more additional training, so it's more focused on your specific use case or need. Or using retrieval augmented generation, which is a framework for LLMs to use external data or data that they weren't trained with, so that they can have a source of truth for their responses. And he went on to say that it's easier than fine tuning, and it also reduces hallucinations. And that's where I kind of fast forwarded in the book to the last couple sections, the capabilities of generative AI and the drawbacks of generative AI. I think we kind of know like the capabilities, and I didn't really take a lot of notes on the capabilities per se. I went a little bit deeper into the drawbacks, and I think we're already starting some of that discussion now. There's just a few that I wanted to call out. He has a list of about 7 or 8 of them. Number one is hallucinations. So if you don't ground your LLM in its use case or the data that it can use, then it's going to make something up. It will answer your question unless you tell it specifically. If you don't know the answer to the question that I'm asking you, say no.
Right?
It's going to give you an answer. It's
with his whole chest. I mean, and it's
very
wrong.
Confident.
And I have a coworker who will fuss and cuss at Amazon Q, whatever, and he tickles me because that exactly. Wait a minute. Let me make this clearer for you. Don't be sending me no nonsense. I laugh because when you're working with someone and you watch their work process, and I'm just like, he's makes me laugh. But to your point, daggone well, because enough about the subject matter that when something is returned to you that is nonsense, you have to have that discernment to know it's nonsense. That's why it's always trust but verify. When you're dealing with generative AI, don't take it as the gospel, because you could really hem yourself up doing that.
Yeah,
So
and honestly, I think for us as experienced technologists, that's kind of our superpower compared to people who are just now learning technology or getting into tech, specifically something like programming. When you have a prompt, you say, "Hey, AI, generate this thing for me," and it gives you some code back. If you're unexperienced or uninitiated, you're taking that as truth. And you're
yes.
like, well, hey, the thing gave it to me. It's got to be good, right? But we have the battle scars of having to write this code ourselves a time or two. We can look at the output and be like, Chat GPT, Claude, for real. Like you're gonna do it like that. And I think one of the when it was really kind of like eye-opening, revealing to me is and this was early on, this was a couple years ago. Software's gotten better, but I was working with Terraform using I can't remember which model it was, but I was like, hey, write me a Terraform configuration that does this. And it was giving me stuff that was not valid Terraform at all. Like it looked super clean, super bad. Like it said, oh, hey, a Terraform output must look like this. And I could probably do this command or this, keyword or whatever. And I was like, that is not correct. Like I didn't even have to compile it. I was like, that is definitely not going to work. And then I said, I told her, hey, this is not going to work. And then it started giving me like JavaScript. And I'm like, why are you giving me JavaScript now? I thought we were talking Terraform.
People pleaser that it is. It's trying to give you what you want.
Yeah, no, that was crazy to me. But okay, my next point for the drawbacks, non-determinisms. This is one of my biggest gripes when I work with AI. And to your point about the image that you created with the text, the author created the image, you use the same prompt to create a similar image, and they were very, very close, right? That's almost determinism because you know what the result is going to look like.
Right.
But in non-determinism is you're getting different responses for the same prompt.
And it's like,
yeah, it's not algorithmic. Like 2 + 2 is always going to equal 4, but if you give some sort of, random, not even call it random, but if you say, describe to me the clouds in the sky, you could put that prompt in the same model a couple times and you're going to get different responses every time. And that can be, depending on your use case. I mean, that's just kind of a random off the top of the dome use case. But depending on your use case, that could be problematic. If you need consistent responses, then you have to ground your model either with RAG or with some sort of fine tuning or with some sort of rules that say, hey, if you don't know the answer, don't answer, or only use these documents, use what's in these documents, to form your answer. If you can't find your answer in here, then don't do it. So yeah, that's one of my biggest gripes is non-determinism.
There's more gripes. There's more downsides.
Yeah. Well, and I only put a pin in one other one, and then I'll turn it over to you. Well, and I could comment on some of the other ones, but the limited context window. And we talked about it, or I mentioned it before when I said the decoder stack of the transformer model, that's the part that takes all the inputs, all the representations, all the training stuff, and it tries to produce an output. And depending on the amount of RAM that you're allowing your LLM to use, because most likely everything's going to be held in the RAM of the system that's running the inference, you could run out of space, right? I think Gemini might be one of the leading context window models with, like huge context window. I don't know what the scale or the parameters or the metrics to determine or how to share that, but it's got a bigger context window than most. But what you'll find when you realize the model that you're working with is running out of context is when you have to explain yourself again. And I have had this problem with Chat GPT where I'm working with a document and I'm like, hey, format your headers like this. The first couple times, boom, 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 he's got it, boom, boom, boom. Then all of a sudden it'll change. And I'm like, hey, Chat, I told you to format your headers like this. And of course, overly apologetic, overly enthusiastic. My bad. So sorry. Let me go back, to doing it the way that you described. I'm like, okay, thank you. But yeah, that the context window can bite you. And there's ways around it now. There's tools that people have developed that allow the LLMs to hold more memory without extending the RAM that they're using. They write to disk or read from disk or that type of thing. So there's ways around it, but that's another thing to keep an eye out for.
Okay. Well, there are a couple of more. If you're reading along, you'll see that there are a couple of more drawbacks, but those are really the big ones. The ones that you hear about, the ones that you probably contend with on a daily basis. There's a cost factor with everything, and a lot of people aren't building foundation models. So, that's probably not our
it's not our concern,
but it's definitely someone else's concern. And recency. Again, you can't constantly train models every day, because that it's very cost prohibitive, and you may not have the latest and greatest of information. Say if Terraform comes out with a new version with new functionality, and you're checking for it and it's like it's not there, and then it starts making stuff up. So that's a lot of upside. I agree. But as with anything, you have to balance the good with the bad. So I live and breathe in Gen AI all day, every day. So I'm not hating. I'm, anybody who uses it for however they use it, I love that for you. But hey, I use it the way I use it.
I know. Hey, if you like it, I love it, right?
That's the saying. Thank you. I couldn't have said that better myself. So what's next?
What's next as we wind down? Let's get into this quiz.
Please.
I got, excuse me, 2 questions from both chapters that we covered.
Can I say something?
Chapter 3 and 4. Yeah, go ahead.
I got them all right for chapter 3.
Yes. Excellent. I did not.
Shock and awe, because I knew I was trying. Now, chapter 4, I'm going to shut my mouth.
Yeah, chapter 4, I'm going to reread the chapter.
Okay.
In the end. And then I'm going to go back and take the quiz, and we'll talk about it. But let's get into the first question of the day. Chapter 3, question 2. What is the primary purpose of reinforcement learning in AI? Is it A, to learn patterns from labeled data, B, to optimize decisions based on rewards and penalties, C, to detect anomalies in data sets, or D, to reduce dimensionality in high dimension data sets?
Okay, so what if this were a test question? What do? You get rid of
start eliminating the bad stuff.
Yes. So what do you think the bad ones are?
I'm getting rid of C really quickly.
I'm getting rid of D, because that's just a bunch of words.
Yeah, right. Yeah. We haven't really we talked about dimensionality, but reinforcement learning itself doesn't work with dimensionality.
Exactly.
There's other steps.
Exactly.
That take care of that. Okay, so then we're stuck with A and B, or not. We're left with A and B, to learn patterns from labeled data, or to optimize decisions based on rewards and penalties.
So you said it in your comments what reinforcement learning is, and it is B, basically.
It's B. It is B. We talked about deep racer.
Deep racer, right.
And that's one of the ways that you can learn reinforcement learning. Because the whole thing is basically you're scripting a mind for this autonomous little race car, and you tell it, hey, if you steer too far to the left on this curve, then I'm going to take 2 points away from you. So it's like, hey, I'm not going to do that, so it's going to take it easy around the curves going to the left or whatever.
So you won't spill your yak going around those corners.
Right. Exactly. No doubt.
If you know, you know.
Yeah. So that's what it is. Bending curves all through the city in autonomous vehicles. Okay, so yes, reinforcement learning, optimized decision based on rewards and penalties. You already got that one right. Going on to chapter 3, question 5, and this is one of those scenario based questions.
Yes.
A retailer wants to group its customers based on purchasing behavior without using predefined labels. Which machine learning approach should they use? A, reinforcement learning, B, supervised learning, C, unsupervised learning, or D, semi-supervised learning?
Okay, so let's get rid of the bad ones. We'll look at the sentence says, without using predefined labels.
Yes.
So that's a giveaway.
That's a big giveaway.
It's a big giveaway. Okay, so let's cross out, we're definitely going to cross out A.
Yes. Yeah. It's not reinforcement because it didn't say anything about rewards or, discipline or whatever,
Agreed. Agreed.
Yeah. It didn't say anything about that. And if you're not using labels, then it can't be supervised.
Agreed.
So I'm going to get rid of B. And then, I mean, I just know this from reading the book. He didn't talk about semi-supervised learning in chapter 3.
No, exactly.
So this
Exactly.
is a chapter.
It comes in chapter 4.
Yeah, he does get to it in chapter 4. But yeah, so with all that said, I would drop on C, unsupervised learning.
Is that your final answer?
But that is my final answer.
It is Tech Coach Ralph's final answer.
Let's see. We got some. Okay, he's playing along. I'll drop your answer on there, Tech Coach Ralph. And he also guessed the last one correctly as well. B. I'm sorry, I didn't see your comment.
Yep.
But so let's go to the next slide.
Kudos.
See if they line up. Yes, it is C, unsupervised learning. And that's basically when you say, hey, model, here's the data. You figure it out. And the model looks for the patterns and starts to create clusters and calculates the distance between the points in the cluster. And that's when it gets really cool. That's like some really cool stuff that you can work with there for unsupervised learning. Okay.
Cool.
Let's go to the next question. We're getting into chapter 4 now.
Okay.
All right, chapter 4, question 1. Which generative AI model involves 2 neural networks that compete against each other?
Oh, we just talked about
variational autoencoder. Yes, we did. B, the transformer model. C, generative adversarial network. Or D, the diffusion model.
Now, I will say this. I did not do the quiz for chapter 4, so I'm doing it as we speak. I'm doing it right now. So I'm going along to get along. So I will tell you what 2 I don't think it is.
Okay, yeah, please.
When we're talking, you got to eliminate the bad ones to get to the good ones sometimes. Or in this case, you can just go to the good one, but involves 2 neural networks that compete. That's definitely the key model, the key phrase. So I'm going to say A is definitely not it. A is not it because VAE has I can't remember what it was, but that ain't it.
No.
What about I'll let you do it because I'm not sure. I think I have my answer, but
yeah, well,
can I phone a friend?
And I think Tech Coach Ralph is asking if he can phone a friend. No, we're not going to let you do that. We're live on the air. We don't have time to be dialing people up. So all of these models had multiple parts, and most of them had 2 parts. The transformer model had 4 parts: the encoder, the decoder, something else, and then something else. I forget what they are. I just know it had 4 parts, right? So I would get rid of B. I forget what the 2 parts of the variational autoencoder were, but I'm going to get rid of that one.
Okay.
The fusion model, we know that it had a couple different parts, but they weren't competitive.
Right.
Which leaves us with C.
Concert.
Yes, they work together. So I'm going to go with C, mainly because you see the word compete, you see the word adversarial, and it's like that kind of locks it in. So Tech Coach Ralph says he's going to use a high school guess. C is the final answer. And yes, C is the final answer for that one. So we got that one. We did that one as a group. Okay, I think I got one more question.
Okay.
Yes. Chapter 4, question 3. What is the key advantage of retrieval augmented generation compared to the process of fine-tuning? A, RAG requires less energy. B, it significantly increases the model's speed. C, RAG mitigates bias in AI responses. Or C, it does not require the modification of a model's internal weights. So there's a lot going on here.
Okay.
Yeah, a lot to consider. What are you thinking about removing out of the gate?
It requires less energy.
Yeah. I mean, we talked about cost and how AI infrastructure uses energy and is expensive, whatever, but not in the context of RAG. So yeah, I would get rid of that one.
Okay.
We didn't really talk about increasing the model's speed very much either.
I don't think so.
Yeah, I mean, he did go into some sections where he talked about evaluating a model. And there may have been some discussion in there about, the speed of the model's response. Maybe it's something I skipped over. I don't know, but I'm going to get rid of that one as well.
Okay.
We didn't talk about bias. And I think that goes into the training portion of these models. I think this is a good potential answer as a distractor, because you could potentially use RAG to balance out the response of a model. But compared to fine tuning, which is a key portion of this particular question, I don't think RAG is the solution to mitigate the bias, because you could probably do the same thing with fine tuning to get a less biased response.
Agreed.
So tech coach Ralph, who is playing along with us, says in middle school, I'd guess D because it's the longest logical answer, and
I agree.
D is his final answer. Before we reveal the result, why would D be the final answer? And I've got some thoughts on it. You got any you want to share?
Let's see. So why did I choose D? You don't have to change the model. You're appending information to it, if that's the word I'm using. I don't know if that's the way the phrasing, but you're adding information to it that helps you. It helps fine tune without the process of fine tuning, because you're using domain specific information to kind of help it out a little bit. I don't know if it's not called training, because it's not training. The model exists, but you're augmenting it with other data. So you're not changing anything in the original model. That's the key.
Yeah, fine tuning, you actually all the parameters that come with a model, the fine tuning is you tweak those models ever so slightly with additional training if needed. And so you're actually modifying the model itself. With RAG, you say, hey, here's some more data that you can consider before you make your decision, but you're not actually going into the model to make any changes. So let's see if the answer lines up. And yes, indeed, it does. D is correct answer for that. It doesn't require any modification of the model's internal weights.
Sweet.
So we're doing okay with that quiz approach, getting our exam taking chops kind of sharpened up.
This is all part of the fun here. We're really trying we're doing this for all the marbles.
Yes, indeed. And I had put a pin in a story that I'm going to tell, but maybe I'll save it for the next episode, bonus feature or something. I don't know.
So I'm reading some of these chat messages, and I'm finally reading them, because
you're finally catching up.
Yes.
Okay. For you, dear listener, while Angela was being very prophetic about the use of AI to generate stuff, meanwhile, tech coach Ralph was having, he was sharing some of his responses. And I think for example, he says, hey, I've made 4 AI albums and I only listen to those. So he's out there making AI music. And if you, I wish I had the link off the top of my head, tech coach Ralph, I don't have it, but you gotta listen to Go Max off of one of his albums. That song slaps so hard. That is literally one of my favorite songs, and I'll tell you why. So, I usually, like, before I do a presentation or something, I'll listen to T.I.'s Trap Back Jumping, and it just kind of it sets the stage for me. It's like, hey, it's time to get the trap back jumping, get back popping. It's like it inspires me to say, hey, we're about to get this trap back jumping.
Okay.
And Go Max is one of those songs that inspires, or kind of like, it gives me that same sort of motivation. It's like, hey, we are about to take it to the wire. It's 1 second on the clock and we just started. That's a line like from the song. It's like, there's no mercy. You're not pulling any punches. You're going to hit the court, hit the stage, whatever it is, and you're going to hit the ground running, and you're going to go 100% until you finish. And that's what I get from that song, Go Max. So maybe we'll have to play it. We'll have to debut it on the show or something. But I'm really hype about.
Well, I mean, I like a good hype song for real, because music is definitely the undercurrent of my life. It is one of those things, especially hip hop. Don't get me started. That's what I am. There is no separating myself from the music that I listen to. You know what I mean? It's such a personal thing. And what motivates me, apparently you like hype music, like I like hype music.
Yeah.
But music is very personal. So if you can find something that suits you and it speaks to you, and I say go for it. I mean, personally, like I'm not going to get back on my soapbox about it, but do you, boo, in a nutshell is what I'm telling you.
Well, and I'll make one point and one distinction, because we're in bonus time now. So thank you for sticking with us. But the one distinction that I'll make to your point, and I'm on the fence here, where people take songs that we know and love and then totally remix them into different formats, like the 1940s version of something by Too Short. It's like it doesn't fit, and it's like you're taking my man's lyrics and you're repurposing them, in a way that he's really not getting any benefit off of. He wrote the lyrics, they're copyrighted, but you're making new, not even new. You're creating something from his original works. And the licensing on that is different. It's odd. You're like, you got to contribute to, or you need to compensate him for his work. But at the same time, I've heard some of those AI songs that sound really good. So I'm like, what do I do in that sense? Now, for Tech Coach Ralph, who joined the conversation, he's creating original music using AI, and I think that's different than benefiting from somebody else's work. I think in any musician, kind of like us, like as technologists, we use AI every day to create code. Some of that code may have been trained off of proprietary code, or open source code that people didn't license to be used for training AI or whatever, and we make use of it to create our own creations in software, whatever the case is. So there's some lines there. The point that I was getting at is creating new stuff, original stuff from AI. I think it's good. I think it's okay. And I think as a musician, as a technologist, as a person working in legal, wherever you are, you need to know how to use AI to accelerate your craft. Because if you aren't, guaranteed, believe that there are other people out there that are, and they're going to be so far ahead of you when it really matters. So
I love it.
Yeah, very good discussion there. Thanks for prompting that with the
and thanks for Tech Coach Ralph for standing on business. There's something to be said for that. And I love it. I love the fact that we also we can have these conversations and understand other people's viewpoints. That is so important. So thank you so much for rocking with us again and again. And thank you for all your feedback. Can't beat it.
You cannot beat it. Loving the discussion. You gasped. What did I miss? What happened?
Honey, you got 2 chapters on the screen when I know these last 2 chapters kicked my whole association.
They did. Now we put together, and I took the liberty of putting together a schedule that was very accelerated.
Ooh, child. But it's okay. It's okay. You want to know why? Because chapter 5 is a baby. It's a baby chapter. Okay. So we good. We good.
Yes. And so what I had hoped for chapters 5 and 6 is to get back to the foundation of our show, going from cover to code, right? And chapter 5, real world AI applications with AWS tools. I'm hoping it's just another introduction to say, hey, this is what it is. And then chapter 6, building with Bedrock and Amazon Q.
Yes.
Where we actually get some hands-on in the console, hands-on in the editor. Yes, and we'll take it from there with some actual.
Oh my gosh, we shall see. I'm looking. I jumped ahead, y'all. Getting started with Amazon Bedrock, and it looks as if you are choosing your model. We're not gonna tell. We're just gonna talk about it next week.
Okay. Hey, so that's your cliffhanger. Join us next week to see which models we're building with Amazon Bedrock and Amazon Q.
Awesome.
Yeah, it's been real. Thanks everybody for joining us. I really enjoyed this discussion. We were all over the map, but man, it was worth it. It was worth it. Very, very well deserved for the.
I loved it. I loved it as well. Yeah. I love the interaction. I love the feedback that people in the chat are giving us. We can't do this by ourselves. I love the back and forth. And it is fun. Like if it's not, I have a motto, and it's a really, it's a really strange motto to have as an adult. But if it ain't fun, I'm not interested. Like, I like to have fun, even at work. If it's not fun, why are you spending so much time doing it? So this is fun right here. And I appreciate the opportunity to have fun with you and our listeners.
As do I. Thanks for everybody for joining us. We'll see you right here, wherever you're watching us, LinkedIn Live, YouTube, your podcast player, where it is. We're happy you're here. We're happy you're joining us, and we will see you next time.
See you next time.
All right. Bye.